So now let us consider this example. Find the value of x at which f is continuous and determine whether f is continuous from the right or from the left or neither of it. Okay, this is the function. And we see that the break.
Could you like zoom in a little? I can't see it.
You cannot see it?
Yeah, can you zoom in a little?
I'm sorry, I cannot hear you. Oh, zoom it in. Okay. Is it better?
Yeah, that's fine.
Okay. What we need to do is to check if it is continuous from the row. We find a discontinuous point. Okay, this function is a branch function, and the branch, we see that it will be from negative infinity to 0, and from 0 to 2, and from 2 to infinity. We see that the first range from negative infinity, we use the range 1 plus x squared. The second domain here, second part interval, we use this part. And the last interval, it follow x minus 2 squared. Okay, we see that at each interval from negative infinity to infinity, this is a polynomial, right? So it is continuous on this interval. The similar story. This is polynomial of degree 1. So it is continuous on this part. Similarly, this is a polynomial of degree 2, will be continuous on 2 to infinity. The only tricky points are at x is equal to 0 and at x is equal to 2, right?
Yeah.
So we have to consider the limit when x approaches from the left of 0 and we need to find the limit of the function f of x when x approaches 0 from the right. Okay?
Yeah.
We see that the limit of fx when x approaches 0 negative, it should follow the first range. It means we need to compute the limit of 1 plus x squared when x approaches 0 negative, which is?
Just 1.
Correct, 1. And similarly, it is from the right side of 0 and close to 0, so we should use the second range. Which is 2. Okay, now the left hand limit and the right hand limit of this are different. So it is not continuous at this point, right?
Yeah.
The limit does not exist. Okay, at the second point, we do the similar thing. When x approaches from the left side of 2, from the left side of 2, it should follow this range. Which is 2 minus 2, and it is 0. Similar things when x approaches 2 from the right, it should follow the third range, right? X minus 2 squared. Again, this is a polynomial of degree 2. It is continuous on its domain. Therefore, it is continuous at x is equal to 2. So the value of this will be the substitution of this.
So 0?
Yes, the left hand and the right hand limit are identical. So the limit does exist when f of x, when x approaches 2. And it is 0. So this function is discontinuous at x is equal to 0, right? And because you see, we are allowed to pick value at 0 for the first range. It means at the first range, it is continuous from the left, right? Smaller than 0.
Okay.
0 is not in the domain of the second range. So it is not continuous from the right in the second range at x is equal to 0. But it is continuous from the left at x is equal to 2 of the second range, right?
Yeah.
Okay, and that's it.
Okay.
So let us move on to another example, okay? The similar question. It is similar, so we don't need to go over it again, right?
Yes.
So, or let me just quickly write it down. We check on the interval from negative infinity to 0, union with 0 to 1, union with 1 to infinity. Be careful with the parentheses and bracket here. So we need to check at x is equal to 2 and x is equal to 1. Yeah, at 0 and x is equal to 1. And that's it. It will be similar. In another example, it is interesting. Now, the function, there are 2 branches. The first branch will be from negative infinity to 6, and the second branch will be from 6 to infinity, right?
Okay.
So this polynomial is a continuous on this interval, and this polynomial is continuous on the second intervals here. So we can only check at x is equal to 6.
Oh.
It means that we need to check the left-hand limit of this guy when x approaches 6 negative. It is smaller than 6, so we use the first formula, right?
Yeah.
Which is cx squared plus 3x. And this is a polynomial, therefore it is continuous on R. It means that it is continuous at 6 it is continuous, so we can simply substitute the value to this function, which is c, a constant we don't know, 6 squared plus 3 times 6, which is 36c plus 18, right?
Yeah.
Okay, leave it there. We need to compute the right-hand limit, which is the limit of f of x when x approaches 6 from the right. And from the right, we should use the second range, x cubed minus cx. It means, so again, this function is continuous on R, therefore it is continuous at x is equal to 6. So the value of this limit will be the evaluation of this at 6, which is 6 cubed minus c times 6. In order, so we need this function to be continuous. It means we need to set the left hand limit to be equal to the right hand limit. Or it means that we need 36c plus 18 should be 6 cubed minus 6c. It means we need that, okay? We subtract and we add both sides with -6, which becomes 42c, right, equal to 6 cubed, and subtract with 18. Then we need c to be 6 cubed minus 18 divided by 42. And you can use calculator to simplify it.
Okay. I got 8/42.
Is it clear?
Yeah.
Very good. Hold on a second. Yeah, it makes sense. Okay, let us continue. The next one. Here, find the values of A and B that makes the F continuous everywhere. Okay, again, we need to consider 3 ranges from -infinity to 2. This is strictly smaller than, so we use this. Union with 2 to 3, and then from 3 to infinity. We see that these two polynomials are continuous on these two intervals. So what we need to do is to check at x is equal to 3, whether it is continuous or not. And then we need to check at x is equal to 2, right? And then we set the limit on the left and the right to be the same. So it would be similar to previous examples. So we can skip now. Okay.
Okay.
Yeah, just write it down, you see it. Okay, this is interesting. intermediate value theorem shows that there is a root of the given function in the specified interval from interval 1 to 2 of the function. And let us call the function f of x is x to the fourth plus x minus a. Did we do it in class? I don't remember this. Okay, this function, it is continuous, right?
Yeah.
On R. So let us find the value of this function at 1. It is continuous. It is 1 to the fourth plus 1 minus 8, which is negative 6. And similarly, f at 2 is 2 to the fourth plus 2 minus 8.
8.
It is, what is it?
Not 8.
16, right?
Yeah.
Plus 2 minus 8, it will be 18, minus 8 will be 10.
10. Oh, yeah.
So we see that at 1 and 2, suppose this is x-axis, this is y, it is negative 6. If negative 6 is somewhere here, and 10 will be somewhere around here. F at 1, suppose 1 is here, and 2 is here, then we know that f at 1 should be negative 6, this point. F at 2 should be 10, should be this point. So we don't know how it looks like, but we bet that there exists a number n, which is equal to 0 in this case, such that we see that 0 is larger or equal to negative 6, smaller than 10, and 10 is f of 2, and this is f of 1. So it means that from the intermediate value theorem, we say that there exists a number n in a number c in this interval, in 1 and 2, such that f of c should be 0. F of c should be 0. It means that it is c is a root of this function. Therefore, we say that it has a root. Yeah. Is it clear?
Yeah. Yeah.
Okay. Very good.